So BlackBerry mobile spyware, the monkey steals the berries. Is that too boomy? Does that sound boomy? Yeah, I thought so. It's right on my neck. Is that cleaner, better, smoother? All right. All right, let's dive right in. Interactive. You guys want to throw shmoo-balls at me? I like it. I want to hear questions. Not you. All right. So what am I going to talk about today? These are the different major sections of the presentation. Introduction. We're going to go through a bunch of case studies of publicly available spyware. The first half of the presentation is really kind of focused on mobile spyware in general, not just BlackBerry, because that kind of is the greater topic and the greater problem. It's not necessarily it isn't a BlackBerry-specific problem. We'll go through some case studies. We'll talk about the BlackBerry security mechanisms. We'll talk about installation of spyware and what the most obvious methods to get spyware onto your mobile device would be. Effects and behaviors of my specific spyware that I've created for BlackBerry. Technical specifications, I'll go through a few slides, not a ton, that talks about the actual code that was written. And then methods of detection and some future work. And the demonstration, I originally had a live demonstration planned, but due to crappy cell reception in this room, I'm going to be playing a demo and just kind of talking through the demo. I'm not sure whether I'll let the demo narrate itself, because it is narrated, or whether I'll jump through, but we'll play that by ear when we get there. So who am I and why should you believe me? You shouldn't, first of all. Second of all, I'm a senior security researcher at Veracode. I've been a consultant for Symantec, a consultant for At Stake. I've done incident response and forensics for the government before, and there's a couple things I wish I was that I'm not. So let's just dive right into it. What exactly is mobile spyware? Mobile spyware, by my definition, and what we're going to go by for the purposes of this presentation, is an application that may or may not look legitimate at face value that executes code behind the facade. We're not necessarily talking about what I created, because what I created has no facade. It is very plainly obvious what it is. But we're more interested in, say, a video game, a tic-tac-toe, a basic game that grabs your contacts and sends them off the phone. A developer may intentionally add these features or unintentionally if it's a syntactical or logic-related code flaw. And mobile spyware does not require any specific programming language. It's not limited to specific mobile devices or operating systems, and it can exist in any environment that an application can run. So it's the same concept as basic PC spyware. But why would people target the mobile platform instead of the PC platform? That's where the data is traveling. The data is going from large mainframe systems to servers to PCs, now to netbooks, and eventually it's going to be residing on little handhelds as much as possible. So it's a follow the data kind of model. Attackers want the data. They don't care about routing a box to root a box. They want the data. They want to make money on the data. Attacker motivation also includes a lower barrier of entry in the mobile world. There's just generally less security protocols in place currently. It's a fresher atmosphere. It's not been beat to hell. It might not even require compromise of the system if the target is willing to install the application on your behalf. There's always the chance of dangerous modification of data in the handheld and theft of intellectual property. High-end attackers are not going to just be jamming this stuff out on the wire. They're going to target individuals by sending them specific links, specific phishing attacks to your mobile that's going to compromise your mobile and get this type of spyware installed on your system. Think Aurora for mobile. It's a perfect opportunity. So let's just flash back in time. There's a bunch of pictures of some spyware for the PC, or commonly Trojan-style applications for the PC. So in the computing world, we have a number of spyware and Trojans. Some code with pretty GUIs, some is just command line, but they all get the data. The data is the key here. These things have been around for a long time. Why do we still have spyware? Why can't we get rid of it? I mean, what are we talking about here? Is this 1999? There has to be a better way to deal with this stuff. So you'll see a theme in the photos as we go through. I like the monkey theme is going to be throughout this presentation. So case studies of mobile spyware. Real quickly, we'll get into some of the examples. FlexiSpy is a commercial offering. Costs between $150 and $350 reoccurring each year. The pros of FlexiSpy: it's fully functional, allows the target to be monitored using many different types of methods. Covers platforms Symbian, BlackBerry, Windows Mobile. The cons of FlexiSpy: it's expensive to purchase. no source code available, and the data is exfiltrated from your mobile device into a server that they own, and then you have to log into that device to get it. So they capture and see all of your data as well. And they store all that personal data. So if I'm going to compromise somebody with a real offensive nature that I want to gather their data for some kind of criminal activity, I don't want it being stuck on a server somewhere. Who do they market to? FlexiSpy markets to the paranoid, which is kind of interesting. Catch your cheating wife or husband, monitor your employees, protect your children, paranoia-based marketing. They also market to the offensive-minded with bugged meeting rooms, corporate espionage, those types of things. They also apparently don't like antivirus beating them up either, because that last is a quote from their webpage, pretty much slamming F-Secure that they shouldn't be classified as malware, which is kind of funny. Oops, ignore that. Swipe my finger slower. Mobile Spy, another commercial piece of software. It's either $50 a quarter or $100 a year. Again, it covers not quite as many features as the FlexiSpy option, but it also covers Android and iPhone, as well as Windows Mobile, BlackBerry, and Symbian. It's, again, expensive to purchase. It costs money. There's no source code available. You can't be sure what it's doing. And it exfiltrates data to a web portal that, again, you have to connect to, so they hold your personal data. So they're a little bit more covert in what their intended uses are. They're more about children's phone usage and safety of your child, and monitor your employees for potential IP theft. They specifically state you should be careful when and where you use their software to not break the law. So they're a little bit more soft on their marketing. They've sold to 30,000 customers in over 150 countries. So if you do the math, that's $1.5 million if those 30,000 customers only bought the cheapest subscription. My wife is pissed I'm giving this away free. She says she's probably right. I should be selling it. So let's look at some more practical examples. I can't say the name of this carrier, Etisalat. I don't know how to pronounce it. Etisalat, thank you. Etisalat is a cell carrier in the UAE, the United Arab Emirates. In July of last year, it pushed a patch to their mobile BlackBerry users that was to enhance performance of your phone, because they're having performance issues the previous week. The patch didn't actually fix anything. Instead, it installed spyware on the user's phone that was controlled over BlackBerry pin messaging, and the spyware stayed hidden on the device. It captured outbound emails, outbound SMS, and it was designed to be remotely enabled or disabled by the carrier. So this comes from the carrier right to your phone. The only reason it was caught is it had some buggy code, and it ended up draining batteries on a lot of targets, and was discovered. People reverse engineered it and publicized that it was found. The analysis was actually quite easy. Some of my coworkers did some analysis on it, and it was easy primarily because the jar was included right with it. So then we have Bugs and Phone Snoop. This stuff was released at Hack in the Box 2009, this past October. So as you can see, this is all recent stuff, July, October. Excellent talk by Sharan Gunasekara, I think is how you pronounce it. Chopstick is his handle. He released three applications at the conference. Bugs, which is a spyware application that exfiltrates inbound and outbound emails. He released Phone Snoop, which is a remote listener for ambient conversation. So essentially you can call into the phone, it turns on the speakerphone and listens to the room. And he released Kisses, which is a detector for bugs and other bugging style of applications. So just so the BlackBerry folks in the room don't think that I'm actually trying to pick on BlackBerry specifically, let's talk about some other pieces of spyware that have infiltrated the mobile arena. Detected in November, this one was is actually in the iTunes App Store. It made it into the App Store. Storm 8 was the name of the company, and they released iMobsters, Vampires Live, a bunch of other games. And Storm 8 essentially would farm your phone number from your phone with these games and store it server-side. It was over HTTP, if I recall, not even HTTPS, which makes it even worse. And they claimed that they accidentally put the code in for development for debug reasons, that after they were called out on it, of course, that it was there for debug reasons, inserted an error and was never intended for production. And they've since modified their games to no longer do this. But what's interesting is these were available via the iTunes App Store. So there's a link at the bottom that talks about the news article for it. Symbian also had a problem. It was available via malicious websites in this instance. And it was essentially a full-on botnet for mobile phones application, which was not very hidden at all. It was generally a botnet application. Once installed, it could send data out, including your phone information, your network information, via a web connection back to a targeted server. It could spam phone contacts for continued distribution so that it could continue to distribute itself. It's essentially a botnet for Symbian mobile phones. What makes this one really interesting is the binary is signed as safe by Symbian. Turns out the process at that time, I don't know if it still is, but the process at that time was for them signing and stamping a binary as acceptable and safe was that it passed F-Secure virus check. And maybe was manually inspected. They had they would select a certain percentage of the applications for manual inspection. So basically, if you didn't get a real virus or a known virus in there, you could be stamped safe by Symbian's key. And that one was. So the 09 Droid banking app attack, this one's Android. This guy created, I think, 50 or so banking front ends and got them into the Google Android marketplace. From my understanding, they didn't actually do anything malicious. From the ones that I know, people have reversed a bunch of them, and they weren't malicious. I think he was just trying to get 0.99 euros for each download and trying to grab it quick, and he did. He had a ton of downloads of these. But it was a perfect opportunity to steal data, exfiltrate data, grab your banking credentials. He just either chose not to use it or we haven't found the ones that he did it in. So it was approved and downloadable from the Google Android marketplace. Google didn't even look at it. Got it up there, put it up there, go ahead. So the point I'm trying to make here is that in general, the app stores are giving a false sense of security to folks. They think, hey, this is stamped by Symbian. Hey, this is at the BlackBerry App Store. Hey, this is on the Google Android marketplace. It's got to be safe. If I'm downloading from those places, it's got to be safe, right? And it's really not the case. So let's bring up another monkey picture and talk about BlackBerry's security mechanisms. So I want everybody to know RIM takes security very seriously. Here's a list of links that talks about the security mechanisms and how to protect your phone. Read them, it's good stuff. The BlackBerry security mechanisms, of all the mobile device operating systems today, RIM is, in my opinion, and likely the securest platform. It is by far the one that has the most granular configurations to add security at the application level, among other things. It implements encryption, application level security, corporate level security. And when you configure it properly, it can be a very secure platform. When the SSA, the Etisalat issue occurred, RIM put out a quote, and it's something that I think I should read exactly here because I think people really need to remember this. But RIM would like to remind our customers that all smartphones can be used as multifaceted application platforms that enable their owners to choose and install a wide range of applications to suit their needs from a large number of third-party developers. But careful consideration should be given when determining which applications are allowed to be installed by the end user on the device. The BlackBerry platform has a number of built-in security measures that require the smartphone user to explicitly agree to install and authorize an application. So at the end of the day, the security of your phone is your problem. And that's really the point of that statement. And that includes not just BlackBerry, but across the board, all the marketplace owners and all the mobile platforms. At the end of the day, the security of phone is still your problem. So they're good, they're secure, that's great, that's wonderful, but does that really matter? Interesting stats. Only 23% of smartphone owners use the security software installed on their device. It's a very nebulous stat. What does that mean? Did you set up the password? There's a number of different things that can mean. But let's assume for a moment that that's any kind of security thing on your device. If only 23% are turning on the password to log into the device to actually unlock it, how many of those are going through on an application-by-application basis and securing the stuff they download from the App Store? It's much lower than 23%. 13% of organizations currently protect from mobile viruses at all, which is also a very, very low number. And another interesting stat is that 54% of organizations surveyed plan to deploy mobile antivirus products in 2010. So it's up and coming. This is where the malware is headed. This is where the target is going. So let's talk about some of the individual security mechanisms implemented by RIM for the BlackBerry devices. So code signing. There's a subset of the BlackBerry API that's considered controlled. For some of the code to be executed and for some of these APIs to be called on the handheld, it has to be signed by the signing key, by a RIM signing key. Controlled APIs are split into three categories: runtime APIs, BlackBerry application APIs, and BlackBerry crypto APIs. It's fairly painless to get access to get your own code signing key. It's basically as simple as filling out a web form, paying $20, and waiting 48 hours, and boom, I had my keys. I did it in a matter of minutes, received my keys the next business day. I can now sign my code, and it can now execute on any of these controlled or protected APIs. That being said, they used to allow people to use the prepaid calling cards to register these, which will give you full anonymous keys, but that had been limited. I tried to do that, and it was stopped. So you might have to steal a credit card once or do something to kind of limit or to kind of bypass it a little bit. So they are trying to actively work on this problem. Then the next thing you do is you install the keys into the signature tool. Right, so what they do is they take your credit card to pay the $20, and then they compare the name that you're registering against the credit card name.
So if I get a temporary credit card like a vanilla Visa.
It has to have your name. The vanilla Visa won't have your name in it.
You can go online and set the name yourself.
Well, okay. According to my friend here, you can go online and set the name yourself. So if you do that, you'll be able to bypass it. Another thing that I was going to do and didn't try is that PayPal actually allows you to set up your own credit card, one-time use credit cards. So if you set up a PayPal account with a fake name, sell something on eBay, get the money into the PayPal account to cover the $20, and that has your name mapped to that credit card, that would probably work as well, although I haven't confirmed that. So the code signing process itself, once you've got the keys installed into the signature tool, applying the appropriate signatures to the code file that's generated is very straightforward. Basically, when you request a signature from RIM, a hash of your code is sent to RIM, and presumably, and actually confirmed, I've asked some folks, is stored for later repudiation so that they can see who's signing what code. But they don't get access to your source code itself, so they don't have any way of knowing what your code does, just that they're going to say, yes, you're using this particular API set, this particular API set, yes, we're okay with it, and we can actually track it back to the key that signed it. Once the signature process is complete, you can deploy it to a physical handheld. Not a very high barrier to entry. It's trivial to acquire anonymous or otherwise untraceable keys, and I'm sure you can think of a million ways besides the couple that we just mentioned. They also have IT policies. IT policies requires a connection to a BlackBerry Enterprise server. It's the highest level of security permission, so to speak, on the device, and is typically pushed from a corporate IT standpoint to the end user device. This policy can restrict a large number of events from happening on the device. It can limit access to third-party apps, allow or deny intranet connections, allow or deny internet connections. These IT policies are generally defined as a default allow, although there are some that are limited, and I'll show you those in a second. And in RIM's defense, balance really is required here with regards to default deny type positions, because if they go and they block everything as denied or block everything as prompt for every kind of resource access, they're going to get a backlash from users. Specifically, they're going to get a backlash from the end users. Corporate, not so much, but the end users would flip out if they had to get prompted at least once for each access. Yes?
Do you have any sense of how common it is for corporations to actually modify the default policies?
No, I don't. I did not find any stats that talk about the modification of that. But I know there's, I think there's like 400 different default policies in the Bez server. So they're very difficult to know what does what. So and there's tons of options within those policies. So it's very difficult to know which ones are the right ones to turn on. And they're generally going to be a little bit on the lax side because they don't want the backlash from the end user. So then there's application policies, which are similar to IT policies, but they operate one level lower at the handheld itself. These aren't controlled directly by the BES, but they may be superseded by the BES. So if the BES pushes you can't install third-party apps, you can't change that by using an application policy. But if the BES says you can change it at the individual handheld level, okay? So it can be superseded. The policies can be more narrow and secure, but never more lax. App policies are typically used to enforce resource and connection type activities on a per application basis. And this is where the end user should be responsible for ensuring that their applications are not accessing resources outside of the expected norm. Again, these are mostly default allow policy across the board. So let's look at those policies in detail. So this is a 4-7 chart I made for policy application permissions, default third-party policy application permissions. Green indicates that the permission is allowed by default. So when I install a third-party application, all the green things I can access with that third-party application. The yellow things are going to prompt, and the red things are going to be inaccessible to me. The bottom row there is the important row. Email data, organizer data, files. You can access a lot of the content on the phone by default without getting a trusted access permission. This is a 5.0 version, so they changed it a little bit. They added a couple of boxes here, but again, the bottom row, email data, organizer data, files, that stuff's all accessible to the application. And this is without pressing the little prompt that says, do you trust this application? This is by default. Now, again, you can go through and harden all this, and you should, but if only 23% of the people are even using any kind of security on the phone, what percentage are going to go through on an application basis for applications that they're downloading from the App Store that they think are safe in the first place? Very few.
Problem is if you take away file permission, it can't even access its own files.
So it's got its own problems too if you start to harden it. I mean, the right thing might be to do is to make them all yellow, right? So that the first time you run the application, you don't say yes to the trusted, you make them all yellow and it prompts you. So that when you install your tic-tac-toe game and run it and it says accessing contact data, you can say, no, you're not, and turn it off. Or you can say yes because you want to share your contact data with tic-tac-toe, and you can check the little box that says always allow this, and you'll only be prompted once. So let's look at trusted for 5.0. Looks pretty much the same. Still largely a problem. It's going to end up being a problem of user education and default security settings to limit the effectiveness of spyware on these devices. The good thing is RIM has the options to make this happen. Other platforms don't even have the option at this point to make these types of things happen. So RIM is in a unique position to really secure and shore down the devices themselves. So let's talk about installation methods. This is not a worm that I wrote. This is not a virus that I wrote. It does not propagate itself. It only tries to hide itself minimally. For example, when its command and control channel is over SMS, I do not hide the inbound SMS messages. They will appear in the victim's inbox, and that's intentional. So installation methods were not necessarily something I was researching as far as trying to exploit the device or anything like that. That wasn't my goal. That being said, we should talk about them. Common installation methods for applications in general are accessing a website using the BlackBerry browser and doing an OTA over-the-air installation of the application by using the JAD file. Running the application loader tool at the BlackBerry desktop and pushing it from the actual PC itself to the device. You can do a BlackBerry Bez push of the application to the user community. Or the most important one is get it into the BlackBerry app world and let the user do it for you. That way you don't have to compromise, you don't have to social engineer, you don't have to do anything. Just push it up to the BlackBerry App Store and make it look really nice and pretty, and then grab all the user's data. The app marketplaces across the board are generally operating in a browser beware stance. You get what you pay for, guys, with regards to the security of these applications. Think 2 cows in 99, think shareware sites in 99. If everyone went through a single shareware site back in 1999 and we could have secured those shareware sites for all of the applications, we would be in a great position now with regards to shareware, or with regards to malware. We got a unique opportunity here. We need to embrace it and use it. So the installation files themselves are the code files. It's a proprietary format developed by RIM. It contains the compiled and packaged application code. We have the JAD files, which is essentially a descriptor that provides pointer and information metadata about the code file, holds a URL pointer and other items. That one's required for over-the-air installation. We have a jar file, which is exactly like a Java jar file. It's the same thing. Multiple classes, metadata, those types of things are in it. That's not required for the installation of the application. And then an ALX file is an XML-based application descriptor file. Very similar to the JAD, it contains a pointer to the code file along with some application metadata, and that's used for the BlackBerry Desktop Manager Java loader-based installation of applications. What? That's me in the morning. I failed to mention, thanks to Jack Daniel in the back, if anybody does need hangover medicine, we have it. So, all right. So effects and behaviors of my spyware, which I call TXS BB Spy. What does it do? So I took all this information, I took all these ideas, these concepts, and I went through the BlackBerry API. Somebody needs hangover medicine. And wrote a proof of concept reference implementation of a BlackBerry spyware application. Again, does not try to hide itself. It's noisy on purpose. It demonstrates how to program a piece of spyware for the BlackBerry device. I did implement hiding from the little process list thing, and I did implement the code that when you reboot the phone, it'll auto-run, and it also runs as a system module. So I did implement those things, but I didn't release how to do that, although it's not very hard to figure it out yourselves. So I'll let you guys figure out that piece of it. And one other thing to note is I'm only releasing this in source code format. I am not releasing the binary of this. I don't want to sign a malicious binary with my key and push it out there. So you guys have a little bit of barrier to entry. You got to compile it yourself and sign it yourself and deal with the fallout of that yourselves. So what do I mean by fully functional? What does my application do? It monitors connected, disconnected calls in real time. It can exfiltrate your contacts, your email, your GPS location, your phone logs, can turn on the microphone and capture data through the microphone and send that out as an AMR file. It can monitor a bunch of this in real time and have the data sent off the device, and it can monitor it as single point in time dumps of whatever the contact list currently is. Oops, oh no, wrong button. There we go. And how does it get the data off the device? We have a number of different exfiltration methods and a single command and control method, which was again intentional. But exfiltration-wise, we can send the data off the device via SMS datagrams, email, HTTP GET, HTTP POST, TCP sockets, UDP sockets, whatever method you want to exfiltrate the data off the device, it's within the code. You can see how that's done. I did bind the command and control channel to inbound SMS only. That's trivial to modify, guys. If you want the device to fire up and connect via TCP socket to some external place and send data across that, you guys can figure out how to set that up just by looking at the TCP exfiltration code. So let's get all techie here, all nerdy with the glasses on, and talk about some actual code. It goes into detail about a few of the options, not all of them, due to time constraints and how the code actually operates. So technical methods. I broke it up into 3, possibly 4 technical methods. We have the data dumpers, the listeners, the exfiltration methods, and the command and control. Data dumpers are the one-time data retrieval functions. The fire and forgets, you fire in your command, and it comes back and says, here's the answer. The listeners are real-time monitoring components where you fire in the command and it turns on that listener for that particular thing of interest. And it's on until you turn it off. And then the exfiltration methods are the multiple different ways that we went through to have the data be sent off of the device. And then finally, the command and control channel. So I'm going to go through, I think 2 dumpers, 2 listeners, and then 2 exfiltrators. Like I said, there's more than that, but just for sake of time and to be able to show you a little bit of a demo at the end, I'm just going to go through a couple of them. But you see at the top the important APIs when dumping contact information, the Java Micro Edition PIM, which is the Personal Information Manager API, and also the PDAP API, which is the Personal Digital Assistant Profile API, are the ones that we use here for this exfiltration, or for this capturing of contact information. And using these APIs, we get an instance of the PIM, which is the information manager, and then an object that holds the contact list in read-only mode. And we enumerate through the items in the contact list and send it to our, if the field is something we're interested in, we then send that field to our exfiltration method and send the data outbound. Pretty straightforward. Here's another example of a data dumper. This is the dump microphone example. One thing that's of interest, I don't know if you guys caught it when we were going through the grid of permissions. Recording was yellow by default and by trusted across the board for 4 and 5. So this one, or it was set to prompt. So this one actually requires you, it's going to prompt the user. So that's something to keep in mind with the dump mic stuff, is it's going to prompt the user and say, this is trying to access your microphone. So it's a point to keep in mind. So in this example, we enable the microphone on the phone and listen to the ambient room noise. After a set amount of time, which I actually have configurable in a, I don't know if I released that part in the source code, but it's configurable in the current SVN tree. We close the microphone after that specific amount of time, and save the data and exfiltrate it. We base64 encode it and send it off the device as a big blob in email or however you're sending it off. And on the other end, you just base64 decode it, you get an AMR file, and you can play yourself the audio. We do that by creating the player using the capture://audio function to manager.createPlayer. And then we set up a record control and an object to hold the recorded data, and then just start the recording. Close it, commit it, finalize it, and send it off the device. So now we're going to move into listeners a little bit. The location listener is a really cool one. We create a listener that implements the particular interface so to do the listeners, it's slightly different. You create a class that implements the interface that we're interested in. So for the location listener, we create a class that implements the location listener interface. And then we get an instance of the location provider class and the location listener with the first parameter of our custom class. So what that does is it actually uses our class and calls the events through our class prior to passing the events through to the normal location. So in this particular case, every time an event update is the one I trap. Every time a GPS update event is fired, our class is called and our particular method is called so that we can then trap that in real time. And you'll see the LL there is a new instance of the local listener, and then the LP. And the ones, I forget what they all stand for, but one of them is every second it's going to fire a location event and pass it off to my code. So here we have the SMS outbound listener. Creates a class that implements, again, the send listener interface. We add the send listener. And then once the send listener is added, every time that the specific events that we're interested in this case, the outbound SMS occurs, we can trap that and send it to the exfiltration method. The PIM listener is just like the other listeners. Again, this time we trap item added, item removed, and item updated methods by implementing the PIM listener interface in a custom class. And we trap all of those and exfiltrate the updated, added, or deleted data so that you can see that in real time. So now we move into exfiltrators quick. And I know I'm hauling here because I have a 13-minute demo video, and I want to make sure that we can at least see this stuff in action at the end. So exfiltration-wise, we have a number of different methods. This one is the SMS datagram method, which, by the way, if you have a lot of contacts, you don't want to use this. I learned that the hard way when I sent 600 SMS messages off my phone because I dumped my entire contact database by mistake. But I'm sure my employer is happy to find that bill. So the first step in SMS datagram is to open a connector to the SMS, and you see here the pnum and then port. This.pnum is configurable from the command and control, so you can set it to whatever pnum you want. I could have made the port configurable as well. I chose not to. And then we create a new datagram and convert the message that we got in from the listener or from the individual dumper, convert the message we wish to send into a byte buffer, and we send the data into the datagram, pack the datagram, and jam it out the wire with the send method. We also have HTTP GET POST. And this is a second example of an exfiltrator that was built into the code. The GET model uses the connector method that we saw before. It uses a string of HTTP ://URL/message. The URL itself is, again, configurable, so we can say we want to pass the data to a domain that we own, and then we append the message as a /message at the end of that GET request. And all we have to do is look at the logs, capture the data, parse it out, and drop it back into whatever we want. Post method is similar. That's on the bottom half here. I actually exfiltrate it in two spots in this example. You'll see the second line, I'm actually setting the data to be the user agent. So just as a secondary example of how you could do it. They could do the same thing in the gets, but I did it in the post there. And then down at the bottom, you see the OS write, where I'm jamming the message bytes into the output stream and sending it out the HTTP post data. So conceptually similar, but slightly different programmatically. All of the listeners are threaded-based exfiltration, so I spawn a thread for those. By this, I mean whenever a listener exfiltration is attempted, we spawn a new thread. So the operating system and event queues don't bog down waiting for responses. Again, that 600 SMS message thing I did by mistake told me I had to thread those listeners because it just bogged the crap out of my BlackBerry when I was doing debugging. But it allows us to queue the messages outbound if the network is slow. So to do the threaded exfiltration, I extended the thread class and created a custom threaded send class, I called it, and then used the run method within the threaded send class to call the exfiltration function, which actually sends the data outbound. So I just wrapped it in a thread, essentially. So there's the commands. Command and control is locked to inbound SMS, as I mentioned. We initialize a listener at application startup to listen for any inbound SMS messages, and if you've set when you compile it, if you set it to be a system module and a auto run module, it'll happen after reboot automatically, so you don't have to worry about getting the user to actually rerun it each time, which, by the way, is blocked in 5.0. So you can't set it as, I believe you can't set it as a system module in 5.0, but whatever the case may be, 5.0 has limited some of that functionality. So essentially the way the command control works is if the inbound message doesn't match any of our commands, we pass the message through to the inbox, the SMS inbox cleanly. If it does match our commands, we execute our individual command in a big case statement. I mentioned I did not drop the code. I did not drop the inbound commands. I left them noisy intentionally, but it should be easy for you guys to figure out how to either move it to like email or move it to TCP or something to that effect. So those are the commands. They all stand for something like PH-LON is everything. TXS is my initials, first of all. I should probably tell you that. PH would stand for phone listener on. PHL off would be phone listener off. PIM on is the information manager on and off, the listener for it. SLIN on is the SMS listener inbound on. So the rest are pretty logical. The commands make sense and should be pretty straightforward. The no authentication on this code. So if you infect a phone and somebody else figures out that it's infected, they'll be able to do the same things you will. So keep that in mind if you start playing with the code. Methods of detection and future work. This is kind of the point of this talk is where do we go from here? So I've created this proof of concept code so people can understand that this stuff is possible and is already being done in many, many places. But where do we go from here? How do we make this better across the board? First of all, additional operating system prompts would be great. I know there'll be backlash. I know RIM would not necessarily think that's the best thing in the world to do, but remove the trusted application prompt and just make everything prompt by default so that when you run an application for the first time, it prompts up a box and says, this application is attempting to access your contact database. Do you want it to? And then it's on the end user. Now, you guys can do that yourselves, but it would be kind of neat if RIM put it that way for across the board. Generally, we're still using signature-based, and that solution is just not going to work. That's how the current antivirus world is failing, so we don't want to worry about signature-based. Sandbox-based execution still requires you to execute it in a sandbox, and you can't ever ensure that the execution executes everything within the binary, so you can't be entirely sure that you've executed full functionality of the application. So that's not going to work well as a detection method either. The most effective detection method would be static decompilation and analysis, which is difficult from an automated perspective. But conceptually, the idea is we decompile the application, which should be straightforward given that it's Java wrapped with their proprietary code format. So if we can reverse engineer the code format, get the Java JADed out, we should be able to manually inspect what each application does. But enumerate the sources of sensitive data. Whenever one of the applications that you've downloaded is touching data on your phone, get a list of that. Then we enumerate all of the exfiltration sinks. We look at all the ways that a binary can send data outbound. So if the binary is calling an HTTP outbound socket, we enumerate those for that particular binary we're looking at. And then we map the control and data flow for tracing and sensitive taint tracking between source and sink that we've just defined. And if we compare those findings, we say, okay, this binary looks at contacts, and we trace it through, and it sends that data out via SMS. Okay, it potentially could send that data out via SMS. We need to know, okay, is that an accepted source of data exfiltration for this style of application? Is that something that the application is intended to do? And raise red flags when that is not the case, and question why that's the case. So again, you really need to target the binary here. So future work, reverse engineer the code file format, as I mentioned. It's funny enough, I was researching online, looking if anybody had done this, and if anybody else knows about anybody who's done this, let me know. There's one guy who was spending some time reverse engineering the code file format, and he It was on some forums, and he was posting some examples, and he got to the end of the food chain. He's like, I think I got it, and then poof, he disappeared. Never to be heard from again. So figure that one out. Continued research into unobstructed installation methods. That would probably require exploitation and would probably be patched and fixed fairly quickly by RIM. But it's obviously some additional great future work, offensive future work that should be done to help harden the device. Maybe infect some PCs with a virus that acts as a distribution hub so that we can get the worm onto the PC, so whenever they plug in their BlackBerry, it jams the spyware onto the device. So that's a potential infection route. And last but not least, we need to research some additional exfiltration methods for tunneling, which I already have in the works for the 2.0 release for non-prompting exfiltration. So let's take a quick look at the demonstration. My little pulp monkey here is showing us.
Hi everyone, this is Chris Eng from Veracode Research. Today we'll be demonstrating.
Oh, nice.
BB.
QuickTime crash. All right, I just got owned. Hold on. There we go. Drag it over to you guys. Hold on. How's the play? There we go.
Hi everyone, this is Chris Eng from Veracode Research. Today we'll be demonstrating TXS BB Spy, a proof of concept BlackBerry spyware.
So that's my boss, and we can all make fun of him later for narrating this video.
TXS BB Spy was developed
I'm periodically
to
going to mute the
illustrate how
video
simple
so I
it
can
is
talk
to
over him
create
and fast forward and
malicious
stuff
mobile
because we don't want to be
applications
bored too much
using
by
the
his
handset
yapping.
provider's own APIs.
Like right now.
Most consumers aren't aware of the range text messages starting with TXS
So what we have here is the
EXFIL email.
Hush. What we have here is the a Google Voice system, and you'll see that we send it a TXS EXFIL email command. So this is actually targeting a real phone. The phone number you see up there is this phone right here, and we can actually show the demo if you guys want to play with it afterward. We send it the exfil email command, which tells the phone to exfiltrate the data via email. And I think that's the TXS EM command, which is telling it to which target email to exfiltrate the data to. Those go inbound over SMS. I can't see that. He's yapping about something now. What's that one say? Dumpcon? Is that the dumpcon? Yep, so that command TXS dumpcon actually dumps the contacts off the phone. And what he's going to do now is he's going to switch back
Switch
to,
over to our Gmail account
his,
and wait for the data
the
to
Gmail
arrive.
account that you saw there in the list, and you'll see the contacts come flooding in. He had to refresh a few times. And we see some addresses here. See some phone numbers.
As you can see, we are receiving some emails containing address book entries for Barack Obama, Homer Simpson, and a few other contacts.
Double size the video? Oh. It is?
Let's dump his
Oh.
email now by sending the command TXS
I don't know how.
dump email.
I can't see it. This one? Where?
Again, the spyware will send one email
Which
for
one?
each message in his inbox. We'll switch
Where is
back
it?
to Gmail to watch the data come in.
Right there? Thank you. Oh, good job, Control F. Yeah, you guys are awesome. I'm glad I have all my friends in the room. Control F. Come on. Nice. Now you guys really screwed up my demo. Yes, Windows is awesome. What the hell did Control F do? Jesus. There we go. That's the best I can do, guys. Sorry.
You can see here that one of the messages in the inbox contains the subject line of confidential and a message body containing here are the
So
secrets.
you missed it, but he did a TXS dump email, which dumps the inbox from the device, and you saw the
Now
individual
let's listen
email
in
come
on
through.
the room using the command txs dump mic.
So this is where he's going to dump the microphone, and I was actually sitting. So this is
This will
actually hitting the
activate
real
the
phone, and I
BlackBerry's
was
built-in
sitting out in my
microphone
car, not at my
for
house.
approximately 5
So
seconds.
you'll see later why I say
and then
that.
send us the
Sitting at a
recording
location,
in AMR
listening to some
format.
music. So you're going to see
We
what he
could have
does. He
made the
dumps the
recording
microphone.
time configurable, but this is good enough for a proof.
Shut up. He dumps the microphone. I just told my boss to shut up. I'm sure he's watching the stream right now. So he dumps the microphone out. It comes out in the base64 encoded blob, and then he runs it through a player, and you can actually hear the audio come back. There's the big blob.
Here's the message. It's encoded in base64, so we'll dump it into a file and then decode from the command line.
And this video is going to be available on our website, I think this afternoon, if you guys want to watch it in, zoomed in without hitting Control F or whatever I just hit.
Now we'll play it using QuickTime.
Not for gasoline, is it?
That would have been awesome. That would have been very funny. I didn't even think of that. You can't really hear it. He didn't have his volume up loud enough, but
Hopefully you
I
can
promise
hear
you it was
that.
really playing.
Okay, now let's try a listener.
All right, so I'm actually going to jump ahead a little bit here.
Says
You see he said
SL in
this
on.
says right here, SL out on. He turned on the outbound listener.
Which will do the
He
same
turned on
for
the
text
inbound
messages
SMS
that the
listener.
victim receives.
So he's got bidirectional SMS listening enabled on the
Now
device
that we've
as
done
well.
that, I'm going to use a different phone to send a text message to Tyler's phone and verify that we receive a copy of it in our email.
So he picked up his handheld, I think it was his, or I think he used a different Google Voice account or something, but he sent me an SMS message that I received on my phone while I was sitting in my car, and I sent a message back. So what you'll see is the real-time capture
I've
of
done
the
that.
outbound and the
Let's
inbound
watch our
message
Gmail
to my
inbox
phone.
again. There it is.
So you see the phone number.
We can
It was,
see the origin of the text message as well as the contents.
I'll tell you.
Tyler's going to reply to that message and we'll get a copy of that too. Here it is.
And there's the reply that I sent back. So you got
See that
real-time
he
monitoring of the
replied
SMS
to the
in and out.
SMS that we had previously sent.
Jump ahead a little bit here.
We'll
Next, he
also
turned on.
send
Next, he turned on the phone listener here, PHLON, which is every time the phone makes a phone call, it'll send an email to him that says, this phone called this number, and then every time the phone is disconnected, it'll say, okay, this particular call just got disconnected. He also sends the TXS GL on command, which is the GPS listener on, and the way I believe he set it up is every 5 seconds. You'll actually see him send the command to tell it every 5 seconds he wants to get an update on my location. And that's the TXS G time 5 there that he just sent. That's way too small.
Is there any way to actually listen or record conversations, the audio from conversations?
Well, from a live conversation that's going, not that I'm aware of. But actually what you can do is, let me just pause this for a second. What you can do is set it up to auto answer so that I can call in and I can bug a room by calling into the phone. This will be in the version 2, I think, as well. You call in, it recognizes the particular caller ID and says, oh, this is my owner calling in, mutes the ringer so it doesn't ring, pops open it answers the phone, turns on the speakerphone, and then backs out of the screen so it looks like it's just sitting there.
but what he's doing on
The hard part is actually connecting to the call that's on using the open APIs. This is just using regular APIs, so I have no way to break out of the sandbox, so to speak, and actually listen in on the call that's running. I don't know if I could do that. I haven't really put a lot of time in it. Maybe for 2 I'll look into that. Yes?
You had a problem with it prompting to listen to the microphone.
Yeah.
Why wouldn't you just use the auto answer?
In 2.0, you will. Sorry, yes, absolutely. So he wanted to know if we have the problem because when we dump the mic, it prompts and says, do you want to dump the mic? So the user is going to be notified. That was exactly the reason why I went ahead and started to implement the auto answer feature to kind of get around that. Yeah?
What happens if the BlackBerry's in the holster?
As far as if it's locked, I believe it works just fine because I've had it go to sleep. Now, somebody brought up to me this morning, Nick did, he brought up a good point about the memory encryption. When you put it in the holster, it can auto memory encrypt, and I haven't tested that. That's an excellent point that I hadn't looked into.
Okay, let's go back to our Gmail inbox.
Wow, that was perfectly timed. Go ahead.
File back.
So you'll see here,
Here's the phone.
mute him a little bit. You'll see here, you'll see the phone. I made a phone call. That's what's highlighted is the actual call start line. The next line down right here that he's highlighting is the call ended. So you can see that it's tracking my phone calls I'm making. If you look at the 2 underneath there, you'll see GPS data, that it's exfiltrating every 5 seconds.
So let's fire up Google Earth.
I know, the timings are working out well for that. And actually, I'm going to go ahead and stop this and show you this on a different screen. Go away. Go away in speaker notes. There we go. There we go. So actually, I was he tracked me around my hometown, which is cool in and of itself, but I thought this was actually a cooler video. Yeah, okay. No, okay. So I thought this was a cooler video. I actually tracked myself on the way from a gas station near my house to Shmoocon. So we'll just watch this video real quick, and this will finish the demonstration. So I did a little flyby art here. And that's my start. Now I'm not connected to the internet with the laptop right now, so those normally look like little push pins when you have Google Earth connected properly. But this is all off of cache. I kind of saved the video, and we'll jump around like the Incredible Hulk, a million miles up in the air over and over until we get to the end of the thing. Now what's interesting is my coworkers were following me real time with an auto-updating script that would update the map on Google Maps and Google Earth so that they could see where I was going as I was going there, and they could see when I hit traffic, and they could see all sorts of interesting stuff. And if you wait a second here, as soon as we get a little bit further up this map, keep going.
How much battery did it take?
Next to nothing. Took next to nothing. You'll see here where we get off for gas, and my boss text messaged me and wanted to know why I went into this other building, which you'll see. You killed my joke, dude. That's where I was going. I'll give it again in a second. So look, here he actually sent me a text message here, and he's like, what is the other building beside the gas station you went into? Yes, it was a porn shop. No, it wasn't. I actually zoom in a little bit closer here. So it's pretty accurate. It's pretty cool. You see the second building I came in, the building in the lower left was actually a 7-Eleven. And then I went into the other building, the gas station, and got something to drink in the gas station as well and went to the bathroom. So you can see a double stop there. What's also neat is this is set to every 2 minutes. If you set it to every 5 seconds, you can actually, and the presenter yesterday who did the iPhone presentation made this point as well. You set it to 5 seconds, you can see how long I was in a place. By just counting the number of push pins that appear in the bathroom, you can see how long it took me to pee. So it's pretty invasive stuff to be able to track someone's location. You can really get a lot about where they work, where they go, where they habitually visit, stuff like that. And we keep hopping here, and here I am valet parking at the hotel. So in conclusion, mobile spyware is trivial to write, okay? That's one of the primary points I want to put out there. It's not BlackBerry specific, it's mobile spyware in general. There's minimal methods of real-time eradication currently available for this type of stuff or detection. The security model of the mobile platforms is still too loose. BlackBerry is by far the best one that I've messed with, but that one's still too loose. It needs to be improved. We're currently trusting the vendor application store provider for the majority of our mobile device security. We can't get into the point where we have a false sense of security from those providers. So our monkey picture to end is the monkey does indeed steal the berries. Any questions? I have a demonstration phone here. If people want to see me afterwards, I'll give you the phone number and you can feel free to send it messages and mess with it and play with it. So. I have not gone into those areas yet, but I have a gut feeling I'll be there in the next 6 months.
Why do you feel you're qualified to generalize the security and access matrix for the other types?
Because of the minimal research I've done into it. So if, yeah, throw a schmooball at me if you call shenanigans on that. Any other questions? The source code should be available, if not now, within the next hour or two. It's already going to be on a blog post at veracode.com/blog. And the blog post is scheduled to go out in the next hour or two, so check back this evening if it's not out soon. Thank you. There, hold on. Oh, hey, we actually ate at Source. We sat at a table at Source, and I was with Zach Lanier.